Okay, students, today we will be doing some problems on quantum mechanics. See, the first question is, given the wave function of a particle, probably this will be your last part of quantum mechanics. So, given the wave function of a particle, psi x, so you can see this is a one-dimensional wave function. It is a one-dimensional wave function. So, psi x is, let us say, kx cube for x between 0 and 3, and it is 0 elsewhere. So you can see that the particle lies between 0 and 3. For x value 0 and 3, the wave function of the particle is kx cube, where k is unknown. Find part 1a, the probability of finding the particle between 0 and 1, b, the expectation value of x, and c, the expectation value of its x direction's momentum. So you have to remember first, k is unknown quantity, so you need to find out the value of k first. So how do we determine the value of k? We all know from our quantum mechanics lecture that a wave function must be normalized. What was the normalization condition? So the solution is mod of psi square dx, the net integration from minus infinity to plus infinity must be equal to 1. Here we don't need to integrate it from minus infinity to plus infinity, because we know that the particle exists only between 0 and 3. So the limits of integration will be from 0 to 3. Mod of psi square dx must be equal to 1. Remember, mod of psi square dx is the probability of finding the particle within dx. So the probability of finding the particle within dx, a small length dx, is mod of psi square dx. So integration implies the total probability must be equal to 1. Since the total probability of finding the particle within 0 and 3 is 1. Since the particle lies between 0 and 3. So mod of psi square, since psi is a real quantity, its complex conjugate is also the same. So it would be k square x to the power of 6 dx 0 to 3 must be equal to 1. So k square is taken out. You integrate x to the power of 6, you get x to the power of 7 by 7, 0 to 3 equal to 1. So if you put the values 3 to the power of 7, you get 2187 divided by 7 equal to 1. So from here you get k square equal to 7 by 2187, and hence k is root over of this. Remember one thing, in these types of problems, the first thing that you need to do is find the value of k. And how do you find out the value of k? By normalizing the wave function. So first thing, keep it in mind. Before finding any of these, part A, part B, part C, before finding any of these, you need to find out what k is, since k is unknown. And how do you find k? You will normalize this wave function for this limit and you'll find out k. So this is the first thing that you need to do. Now you know the value of k. Now you approach the problem. So the first part is the probability of finding the particle between 0 and 1. So here you can see part A, the probability of finding the particle between 0 and 1. What is this? This is the probability of finding the particle within length dx. This is the I repeat, this is the probability of finding the particle within dx. So what is the probability of finding the particle between 0 and 1? If this is the probability of finding the particle within dx, then the probability of finding the particle between 0 and 1 is integration of this 0 to 1. So just put it. Again, mod of psi square is k square x to the power of 6. I'll be putting the value of k square afterwards. So k square can be taken out. X to the power of 6 is x to the power of 7 by 7. And we know it is, again, so this is k square by 7, or I'm sorry, yes, this is k square by 7, and x to the power of 7 by 7. So I can just put the value of, so if I put 0, 0 is 0 and 1 is 1, so x to the power of 7 becomes 1, 1 by 7, so you have k square by 7. And we know the value of k square is 7 by 2187, so 7 by 2187, 7 gets cancelled out. So the probability of finding the particle is 1 by 2187. This is the probability of finding the particle between 0 and 1. Next, expectation value of x. We know expectation of any observable in quantum mechanics is given by this. The operator of this, that is x cap, must be sandwiched between psi star and psi and must be integrated within proper limits. Here the limits will be from 0 to 3, since the particle is in the region where x is between 0 and 3. So sandwich the operator x hat between psi star and psi and integrate it from 0 to 3. So again, psi star is, again it is kx cube. X operator, you know, if you operate it on psi, you will get the value x and psi. So x operator on psi will give you the value x and psi. So if you take k square out, you have x to the power of 7 dx. 0 to 3 is the limit of integration. You just put the value of k square is 7 by 2187, and x to the power of, if you integrate it, x to the power of 7, you get x to the power of 8 by 8. If you put the limits, you just see this will be 3, because x to the power of 7, 3 to the power of 7 is 2187. Here it is 3 to the power of 8. So you have a 3 remaining, 7 by 8 into 3. So it is 21 by 8, that is 2.625. So the average value of x, that is the position of the particle, is 2.625. So on an average, the particle may be found at x equal to 2.625. So if you make a very large number of measurements, on an average, you will find the particle at 2.625. Since the particle, see, the particle lies between 0 and 3. So the average value of x must be somewhere between 0 and 3, and indeed it is 2.625, which is between 0 and 3. Similarly, expectation value of momentum, again you sandwich the momentum operator between psi star and psi. So psi star is again kx cube, since it's a real quantity. The momentum along x operator is minus I h cross del x kx cube. So you operate this on this first and then you multiply. That was the rule. So k square can be again taken out since it is a constant. X cube is here, minus I h cut. This can also be taken out. I'll take it out. Del x of kx cube will give me 3x square. So minus I h cross, 3 is a constant, 3k square. These are the constants is out, and you have x to the power of 5, and the limit is 0 to 3 since the particle is between 0 and 3. So it is minus I h cross 3 into k square is 7 by 2187. X to the power of 5, the integration gives you x to the power of 6 by 6. And if you put the limits, this would be 3 to the power of 6, and remember this is 3 to the power of 7. So here you have a 3 and here you have 3 to the power of 6. So you have 3 to the power of 7, it gets cancelled out, you have 7 by 6. So you have 7 by 6 minus I h cross px. So this is how you find out the probability of finding the particle and the expectation values. But again, I repeat, for these types of problems, first thing that you need to do is find out k, and to find out k, you need to normalize the wave function.